back, Math 9. Let's continue our polynomial lesson for today. Today we're going to do, like the title suggests, a complex polynomial divisions. One thing that you need to understand related to this method is we do not tend to use tile most of the time, but first part we will use some tile. Second part, which is our majority of the part, we are not going to use a tile, you're going to use algebraic method. As you may notice, this is the part where blank pieces of paper benefit you because we are not doing or going through using a booklet for today's lesson. We're going to do an improv example. Like I mentioned, we're going to do probably one or two example of tile, and then we're going to go through many example of algebraic method, which is what you should know eventually. I want you to write down, let's see, what about, yeah, that's a good example. 6. Something like that. 3x squared minus 6x over 2x. Note the fact that numerator are together, so technically there's a bracket. Think it in that way. Oh, another thing, why don't we just make, sorry about that, easy one first. 2x squared minus 6x over 2x, something like that. If I give you a little reminder, if you use tile situation, you need to decide the denominator go either your vertical or horizontal placement. Let's put that as a vertical situation. So why don't I put 2x? Know the fact that it's a strip and another strip. Like that. 2x squared minus 6x. You need to distribute our numerator evenly using the space that you see inside of a table. That is how we did, except it will be a little tricky because can you see x squared? So that's a fancy way of saying we have to put big square for each of them. And know the fact that I put 2 empty one because of positive, and negative 6, that's color. So if I distribute it, that can be 1, 2, 3, 4, 5, 6. Something like that. Now know the fact that during this process, I need to now rethink. Empty strip is x, empty big square is x squared. So how can I make x squared? Easy answer is multiplying x by x. And know the fact that it should be empty one, so that way positive and positive make positive. If this is colored, then I should color the other one. And that also work for the bottom combination. X and x make x squared, something like that. So this is the only difference compared to the previous example where we deal with a bunch of constant. On the other hand, strip and color, integer, -1 and x give you negative x, right? Something like that. So long story short, our answer comes out to be equal to x minus 3. That is the answer for 2x squared minus 6x over 2x situation. This is how you do, ladies and gentlemen. Let's do more. Number 2. If I have, let's say, I don't want to go too much a big number, so alright, so second example, I created an example over here. Oops, that's negative 8. Negative 8a squared minus 12a divided by negative 4a. As you may notice, we have polynomial, technically binomial expression on the top, and then we have denominator, which is monomial. And all of them have x's, or in this case a, which is variable. It doesn't matter, folks. As long as you decide one of them as, how can I say, either the vertical or horizontal placement as a denominator, then you'll be on the right track. I'm gonna choose horizontal this time for strip. And another thing that you need to be careful is we got a color because it's -4, right? And we need to distribute -8a squared. So now that's a colored big squares. Oh, I gotta do it again because there are 8 total. Gotta extend a little bit. And -12, so 1, 2, 3, well, actually it should be 3 row. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we distribute each of the expression, denominator on one of the outside of the table and numerator, as you may notice, inside of the table. Ignore that, please. That's my rice cooker machine. But in any case, we are combining strip and strip to make square. And as you may notice, it's color. So negative multiplied by positive will give you. Same thing will happen. And the rest, integer tile. So note the fact that that becomes my answer, which is positive 2a plus 3. To be fair, most of the time you can use tiles to divide something and figure out the answer. However, there is a limitation. Limitations. Number 1, if you notice this or not, the limitation is you have to have some kind of divisible integers. What I mean by that is if you think about the previous example, 8 can be divided by 4, 12 can be divided by 4. So if things are divisible, that work. However, if the things are, I'm just going to put only. If it's, however, -8, and you imagine you have -3 over there, 8 and 3 cannot be divisible, and then you cannot use tile. Number 2, it works when you have variables. And when I say variable, literally all of them. As soon as I have a square, but imagine -12 is just constant -12 and divided by -4a, this method doesn't work. Then we gotta use what we're familiar with, algebra method. So let's do that, ladies and gentlemen. Number 3 example. Now we're going to actually create random example, and it's gonna be more complex. For instance, start with an easy one first. -4x squared positive 3x and divided by 2x, something like that. This is a perfect example why tile method is kind of limited. The reason being is, if I think of a divisible pair, these two work. But -3 and 2, these guys do not work. So in order to use an algebra tile, you have to have some kind of consistency. In this case, here's what I'm rather going to do. If you guys remember, numerator and denominator is technically together. So as you may notice, it's bracket. But distribution you gotta do for each of them. It doesn't matter even if 3 and 2 are not divisible. I want you to separate them. So what I mean by that is, first term will be negative 4x squared divided by 2x plus 3x divided by 2x. This still works, ladies and gentlemen, because, and this is a part where we learned briefly last time, x squared and x, this is where we can use our exponent law. They're sharing same base, so that's fancy way of saying 2 minus 1, and x is equal to 1. So, long story short, if I simplify, 2 and 4, they can be divided by 2. So bottom will be 1, above will be 2, 3x and x. Only thing that cancel is x. So in the long term, you notice that negative 2x plus 3 over 2 is how we can express our final answer. And yes, it is possible to have fraction as part of your answer. And from now on, you're going to see this kind of type. Now, this time, things are going to get a little bit more tricky. Let's say we have let's say for this, yeah, why not? 5, something like that. Before we getting into, I think this is a good point of think about our degree of each of a term. If you guys remember, when it comes to something that is squared and cubed, they generally give you how many degree that is. A lot of people think if you have, let's say, 15m squared over n, people tend to just focus on this exponent that is highest and then say this is degree 2. However, it is not. When you look at things that has more than one variable, here's what you do. Consider that n is in fact n to the power of 1. We are looking at these two exponents together if you have different degree. So that means 15m squared and n1, this is 2 plus 1. So in terms of degree, this is third degree. That's something that we're going to learn and apply today. What you are familiar is, like for example, 5n. This is just 5n to the power of 1. So it is 1 degree. Or sometimes you know that negative 25m squared. That give you that 2 is the only exponent. So this is degree 2 or second degree, something like that. But if you have more than one letter, like the example that I provide you, but I'm going to complicate it more, something like that, then know the fact that I have to consider the exponents on top for each of them and then add it. So a and nothing, that's a fancy way of saying a to the power 1. This is b to the power 2. This is c to the power 1. So 2 plus 1 plus 1, that's 4 degree, something like that. This is a little bit of a side note. And the reason we are doing that is because obviously we are having more than one type of variable, and at the same time we are dividing each of the components. So even if 3 and 5 doesn't work, it is important to separate them, ladies and gentlemen. So 15m squared n over 5n plus 3n over 5n. Just like that. Then you will know that n and n, they disappear. N and n disappear. So at least variable-wise it's easy. Other than that, 5 and 3, you can divide it by 5 for both top and the bottom numbers. So 3m squared plus 3 over 5 is what you have, ladies and gentlemen. And that is how you solve complex polynomial division. That's how you do, ladies and gentlemen. Let's do one last one. Ultimating one. What if you have way more than binomial situation and including the constant? So let's use our imagination for this one. To be honest, number 5 is more between grade 9 and 10. But in any case, something like that. This is a tricky example. First of all, you have lots of negative going on, and second of all, you have more than one letter, and third of all, the degree is nuts. Like the first term's degree is 3 because 2 plus 1. Second one is 2, this guy is 1, and when it comes to denominator, you actually have degree of 2 because A and B, that's 1 plus 1. But still, don't get too scared by everything that's going on in here. We're going to make it into 3 different parts. So bracket open, negative 15 a squared b over negative 2ab. Just like that. Seems like focusing has some problems, so. There you go. Sorry about that, just a little bit of fixing. Good. Good. Okay. So negative 15a squared b over negative 2ab minus 2b squared negative 2ab. Note the fact that I kind of put this negative outside, so that means what's inside is positive now. Plus 4a negative 2ab. Something like that. Let's figure out things that you can cancel. For example, the sign. I can cancel and make everything positive. A squared over a, that's a2 minus 1, so just a on the top. B and b cancel each other. So first term turned out to be 15a over 2. Don't make it into mixed fraction, because in high school, as soon as you go to this section, you will know that everything is either proper or improper. Minus, and then you have 2 and 2, so I can divide and simplify into 1 over top and negative 1 at the bottom. B and b can be cancelled, so you have negative a b on the top, and that's it. We're not going to do any sign notation now. 4 and 2, you can divide it by 2 for both. A and a cancel each other. So at the bottom I have b and 2 at the top with negative. Then I can simplify. 15a over 2. Negative and negative become positive. B over a. Negative and positive give you negative sign. 2 over b. And ladies and gentlemen, that's how you do. And this is, how can I say, the lesson for today. It is complex polynomial division. Homework will be shortly follow after this scene.